In this video, I want to explain you what I actually do as a software engineer in 2026. My name is Miguel and I've been working in tech for the past 4 years. I've worked in different industries such as data or aerospace, and I've realized that the way I worked a few years ago is completely different from the way I work now. So in order to give you a precise image on how it's working as a software engineer today, I've divided this video in 4 parts. First, big picture. Second, my day-to-day work. Third, teams and colleagues. And fourth, salaries and job market. So let's start with the big picture of what a software engineer does. Software engineer is a person who builds software solutions to real-world problems. This definition is abstract on purpose because the strength of software is that it can be applied to many different industries. There are softwares for entertainment like YouTube or Instagram. There are softwares for, aerospace, for sending rockets to the moon. There are software for marketing. There are softwares for finance. There are softwares for managing restaurants. Any industry can take advantage of software. I like to make a parallelism between construction and software. And actually, the different roles that you can have as a software engineer are very similar to the different roles that you can find in construction. In construction, there are architects, people who design buildings before they are built. The same thing happens in software. There are people who design software before they are built and who supervise the development, similar to the construction. There are also bricklayers. You can think of the juniors, the people, the fresh out of university that go the first time to Deloitte, for instance. What they do is to put bricks. They are asked to build some part of the software that other person has designed. However, this analogy has some limitations. To be a bricklayer is more or less simple, but to be a software engineer needs some qualification. A few years ago, the need of bricklayers in software was so high and there was such a shortage of software engineers, the salaries went crazy. And here is where AI comes in. AI is a tool that has almost fully automated the task of a software bricklayer. And that doesn't mean that software is dead. What is dead? What is dead is to be a monkey coder. Remember what I said at the beginning, a software engineer is a person who builds solutions to problems. AI is making the task of building easier, but still, a good software engineer is a person who is able to design a solution to a problem, and AI, at least yet, is not connected to the real world. AI doesn't understand what are the problems of humans and doesn't know how to interact with the real world. That's where the current job of a software engineer is. And actually, my current job as a software engineer is precisely very related to these things. And everyone who wants to work as a software engineer in the future should stop thinking only on coding and should start to think on architectures, design, and how to create the products that the people want. There is a huge opportunity for software engineers that can take advantage of this situation. That's why I help software engineers to switch jobs and add $30,000 to their annual salary in just 3 months. If you want to work with me, check out the link on the description. Let's go with my day-to-day work. You can divide the job of a software engineer in 3 parts: developing, reviewing, and communication. Developing is creating the features, programming, coding the features that you have agreed with your company that you are going to create. Reviewing is checking the code of your colleagues and giving them comments and agreeing with them on the developments because you are a team and you have to work in team. And communication is agreeing at a higher level with your technical leader or with the CEO, whoever you report to, and also with your team, what are the features that you have to develop. Also, depending if you work in a company that provides services to another company or a company that has a product, you also will be involved in decisions for product management. These kind of decisions are very close to the customer and also to the business. These are business-oriented discussions that then has consequence at a technical level, at the level of software. And the same thing happens if you work for services. If you work for services, instead of having a product and taking decisions on how to build that product, it's more about having regular meetings with your clients and taking decisions depending on how the project is evolving and what are the priorities for them. In my case, I work designing the control software for aircrafts and drones. This software is the software that makes the drone take the decisions if the drone has a mission which is moving this way. My algorithm takes the decision on which part to move at which speed, such that the drone can make that movement. So in my case, the developing part is to take the right decisions based on information that I have on the drone on what are the best algorithms to perform this maneuver and to code these algorithms. Review is more bureaucracy stuff. It's something that you have to do, but it's something more defensive. It's something that you do. It's something necessary that you do to avoid introducing bugs and to share ideas with your colleagues, but it's not the main task of a software engineer. And then the communication part in my case is to understand the priorities of my company, because my company has different products and I'm usually only working on one or two at the same time. And maybe what I think is the priority for my project is not the priority for the company. So I have to understand what is the priority to make the most of my time. My day-to-day work also consists not only on creating these algorithms that runs on the drones, but analyzing the drone. The mechanical engineers usually give me designs of the drone on, for instance, performance of the drone. How fast can it go? How much time does it take to take off? How much time does it take for him to fly at some altitude? How much energy does it consume? Up to which altitude can it fly? This kind of analysis are usually produced by me and my team. And doing this, I found out that a very good skill to have being a software engineer is to understand data. I've worked before as a data engineer, and when I started in this field, my previous skills as a data engineer were very helpful for the team and allowed me to contribute while I was catching up in this all controls and navigation stuff. The point is that any company generates data and they probably want to access to that data or to use that data to do, I don't know, statistics. In my case, we want to generate data like test of the drone and these metrics, and we want to store this metric and be able to go back or to update them when we get a new design. And data may seem something simple, but it's not simple at all. Data can be generated from many different sources, can be generated from another team of your company, can be generated for other companies, can be generated by yourself. And then this data has to be moved to the right location so it can be consumed or it can be updated. You can think on this like in agriculture. Oranges, there are many different people cultivating oranges, that they all move them to the same market. They sell these oranges, or you can think on data is generated from many sources, and then you move this data to be stored in the right place. So like these people do with the oranges, and they have warehouse with oranges. And then there are people who consume these oranges or the data. And also like the oranges, the data can get old and has to be deprecated at some point. My recommendation for any software engineer is that you should understand databases, what is a data lake, what is a data warehouse. You should have some idea of data engineering, because it's not a very difficult skill that is very profitable. Let's go to the third point, which is the team and the colleagues. So first, the only reason why teams exist is because you cannot do everything yourself and the day has only 24 hours. But remember, the more people you add to a project, the less productive is each people individually on that project. And that includes you for sure. The reason is that communication becomes more and more complex, and in each communication that happens, there can be some misunderstanding. The more people you have in a project, the more of this communication happens, and it's more likely that you have this kind of miscommunications. To mitigate these things, it's important to have good communication protocols, but it's not something necessary at all, or even if you have them, you don't have to be super hard, you can be flexible, because again, protocols are rules, and rules cannot represent all the complexity of communication. So some simple rules can actually help a lot on the productivity of a team, but a lot of rules can be worse than having no rule at all. In my case, my company has departments. I work in the controls department, which is people who design the software for controls, as I said before. And there are other departments like the mechanical engineers, who are the people who actually design the aircraft. And the communication between departments happens, but it doesn't happen too often. So we get data from them and we treat them like a kind of source of data. And we have meetings sometimes, like maybe once a month, twice a month, and we go and ask them, but it's not something super frequent. At the same time, the communication inside the team is something that happens every day. Because, for instance, we have to review. We use a simple process for review, the one on GitLab. You work on a branch, and once that you want to merge, you do a merge request. Your reviewers see that, and they write their comments. And GitLab has already a very good interface and very good protocols for communication. Then there are other kind of meetings, which are more like technical meetings where we take the technical decisions. And if someone needs a technical meeting with someone else, what you can do is, instead of going and saying, hey, can we have a meeting? Because if you ask a person if you can have a meeting, you can ask that by chat or in person. That's problematic because first you ask, can you have a meeting, which is stopping what that person is doing. That person answers later, yes or no, and the other, when, and on Thursday, no, on Wednesday, which time. Okay, you see there are a lot of communication. So the alternative is having a tool like Calendly or Google Calendar or Teams, everything. There are a lot of tools for this where you can see the calendar of the other people and you can set up a meeting with the topic, and the other person can accept or reject your meeting. Then at the responsibility level, there are people who are responsible for some features of our code, of our product. And anytime that anyone has a question about that, knows what is the right person to go and ask. And finally, the rest of the communication is for important events like a first flight of a drone or something. There are usually meetings between these stakeholders, which have the key responsibilities to do checks, to see what we need to start this first flight, and to create action plans for these events which are important in the company. Now you have a complete picture of how the job of a software engineer looks like. Think on what I said at the beginning about the AI. The most valuable parts are the communication and the development. The development, it's important because it's actually building the product, but also at the same time in communication, it's where you take the decision what is the product that you want to build. At the end, if you don't build the right product, your work has no value. So what AI is doing is making this part of development easier, simpler, and you can say less costful. So that has implications, a lot of implications in the job market, and that's why everyone is crazy with the tech job market. So let's go to the fourth part where I'm going to give you some advices about the reality of the tech job market. AI is making the development easier. The bricklayer job. If you are a very good bricklayer and that's your main skill and what you're very good is laying the bricks, you have a problem. You have a problem because you cannot compete with AI. Maybe you can think that right now AI is not good enough, and it's true, the code that AI produces is good, but it's not as good as a code produced by very good senior software engineers who are thinking on the architecture and everything. But this thing will come, and AI is approaching to this level. You can think that there was a lot of value in the production and a lot of value on the communication and on the thinking before, and now the value that there is here, because there is actually a value. The thing is, you are not adding that value. This value is added more and more by the AI. Doesn't mean the software engineer should change jobs. No, I actually believe that there is a great opportunity for software engineers. But you don't have to focus on being a monkey coder. You have to focus on understanding architectures, understanding how to choose the right software architecture for a project, and on doing the things that AI cannot do. AI lives inside the computer and it doesn't have access to the real world. And you, as a human, has a very good interface to understand the world and to understand other people and other people's needs. The future job of a software engineer is going to be to have a person who understands software, understand what is the product created by the AI, understand what is the code that the AI is generating, and at the same time you have something that the AI don't have, which is access to real world, and you can support the work, so you can collaborate with the AI. I can already see that in my job. Where I work is with drones and aircrafts, and there is a good part of my code where the syntax and the code and everything is generated by the AI. But what is the right analysis that I have to do for a drone or an aircraft? It's a decision on me, and a decision on something that is physical, and I understand the physics, the movement. We do real tests, we measure data, we use that data to improve our models of reality, so we are interacting with reality. AI has right now a limitation that it doesn't mind how good it's thinking. It can be an AI that is Albert Einstein and Linus Torvald combined, but if it doesn't have the access to real world, it has a limitation. And there is where, as a software engineer, you understand what is the job of the AI, you understand your job, and you can give a lot of value. And actually, as AI is such a productive tool, you can use your skills as a software engineer to make the most of this productivity, and you can increase your salary a lot. Not everyone can work in robotics or in drones and aircrafts, and that's true, but that's not the only part where you interact with real world. Understanding physics and understanding machines and robots is not the only thing that you can do. Understanding other businesses like marketing, I don't know if your company has a tool for marketing. If you understand what a marketing person does and you understand what is the job of a marketing person, how this person is using the interface, you can improve the interface, because the AI has not very good communication with these people, and many times the people who need the product don't know how to express this thing. It's after you create the product that they see that that's what you need. Even the software developers don't know what is exactly the product that they need. For instance, before Git existed, there were a lot of control version tools that none of them was fully satisfying the need. But it was when Git appeared that Git became the standard and all of the other tools were not used anymore. So that's the thing, being a software engineer that can understand the needs of the clients and having software engineers that have this business-oriented mind, it's the skill of the future. And if you really have this business-oriented mind, I'm sure that you can make much more money than however much you're doing today. I help software engineers to switch jobs and add $30,000 to their annual salary in 3 months. But you have to be one of these engineers, an engineer which has a business-oriented mind. If you are one of these, check out the link on the description, thefreeengineer.com. There you can have a call with me to see if we can work together. Bye.